Hi, welcome to Mr. Lai Chemistry class. Today we will learn 5.7 Properties of Ionic and Covalent Compound. First, we will do the analysis of the properties of ionic and the covalent compound. If you can construct a table and do the comparison, it's much more better. First, we compare the physical state at the room temperature. For the ionic compound, normally they are in the physical state are solid state, while the covalent compound in the liquid form, or you can be a gas form. The melting point for the ionic compound is higher, covalent compound is lower. The boiling point also very high in the ionic compound, low in the covalent compound. Electrical conductivity. Solid, the ionic compound cannot conduct electricity in the solid form, but it can conduct electricity in the molten or aqueous solution. Covalent compound cannot conduct electricity at all. Solubility in the water. Ionic compound able to soluble in the water. Covalent compound insoluble. Organic solvent. Ionic compound insoluble. Covalent compound soluble. Electrical conductivity. The ionic compound conduct electricity in the molten and the aqueous state. So for the question, if they ask, ionic compound cannot conduct electricity in solid state, why? You have to answer because in the solid ionic compound, ions are fixed in a lattice structure and do not move freely. The lattice means they have a fixed structure. It can be a cubic lattice, it can be a hexagonal fixed lattice. It depends. So when the ions are fixed in the structure, they do not move freely, so cannot conduct electricity. If the question asks, ionic compound can conduct electricity in the aqueous solution or molten state, why? Because they can free to move. Covalent compound cannot conduct electricity in all states. Why? Because it consists of the neutral molecule. Melting and the boiling point. Ionic compound have the higher melting and boiling point compared with covalent compound. Why? Because ionic compound they are held together by the very strong ionic bonds. So it have to take more energy to overcome the strong electrostatic force. But covalent compound has a low melting and boiling point. Why? Here you can explain by using the van der Waals force is very weak between the covalent compound molecule. So less energy is required to overcome the weak van der Waals force. So solubility, for the most of the ionic compound, they are soluble in water but insoluble in the organic solvent. This is because the attraction force between the atom of the water molecule H2O with the ionic compound ions. So you can see Na positive and the Cl negative. So the ions from the compounds are strong enough to overcome the electrostatic attraction force between the ions themselves. That means the water molecule H2O, they are able to overcome the electrostatic force among the ions themselves. They can pull away the ions. That's why ionic compound able to soluble in the water, while organic solvent cannot, because they can't overcome the electrostatic force between the ions and in the ionic compound. So the ionic compound unable to soluble in the organic solvent. Structure of the covalent compound can divide into simple molecule and giant molecule. Example of the simple molecule: water, carbon dioxide. Giant molecule, silicon dioxide.
Hello there, and welcome to this video on simple molecular structures and how it links to their properties. So simple molecular structures are things like O2, CO2, H2, F2. Basically, almost all of them are diatomic molecules. There are some that are more like CO2, but they all pretty much are gases. And the reason that they are all gases, very, very much not in focus. There we go, that's a bit better. The reason that they are gases is because of the following. So let's use hydrogen as an example. So here we have some hydrogen molecules. Now these hydrogen molecules have very, very weak forces that actually attract between the molecules. Okay, so this molecule here and this molecule here are not attracted to each other very much at all. Neither are those two. So they all have a habit of kind of spreading out. So they have very low melting and boiling points. And I represent that with MP and BP, melting point, boiling point. Okay, so simple molecular structures often have very low melting and boiling points. The other thing that you sometimes need to talk about is that between the actual atoms within the molecule, we have strong covalent bonds. Oops. We've got strong covalent bonds between those atoms, but it's only weak forces between the molecules. So they don't conduct electricity. As they've got no free electrons to conduct the charge. We've got no ions, we've got no positive and negative charges, so they can't be attracted in different directions to conduct charge either. So simple molecular structures, low melting and boiling points, don't conduct electricity, and it's because of these weak forces.
Let us compare the structure.
Graphite and diamond are examples of giant covalent structures. The arrangements of the atoms can be quite different. Sand contains silicon atoms covalently bonded to oxygen atoms. 4 oxygen atoms are bonded in a tetrahedral arrangement around each silicon atom. Diamond has a very similar structure, where all of the carbon atoms are joined by covalent bonds in a tetrahedral arrangement seen here. In graphite, the carbon atoms are arranged in hexagonal sheets and have intermolecular forces holding these sheets together. These layers peel away when our pencils make a mark on paper, because the forces holding the layers together are intermolecular and are quite weak. So when you are writing with a pencil, you are actually transferring sheets of carbon. Seeing as all of the atoms are joined by covalent bonds, these materials have very high melting points. Diamond is one of the hardest substances in the world, but graphite is quite soft. The structure of these materials also determines their electrical conductivity. Diamond does not conduct electricity at all, because its electrons are locked up in covalent bonds, whereas graphite contains free electrons and so can conduct. Silicon is found in semiconductors, and it is through adding other elements, called doping, that it allows partial conductance, which has applications in computing. Table salt, sodium chloride, and magnesium oxide are examples of giant ionic lattices. Ionic bonds are the electrostatic forces of interaction between oppositely charged ions. This cross-section of sodium cations and chloride anions extend all the way for an
So simple molecule have a structure very small. Normally they are solid, liquid, or gases. While the giant molecule normally have a large structure in the solid form. Simple molecule has a strong covalent bond in the molecule, but weak van der Waals force. Well, the giant molecule, they have only strong covalent bond. Melting point, simple molecule has a low melting point, so less energy required to overcome the weak van der Waals force between the molecule, while the giant molecule has a high melting point. The use of the ionic and the covalent compound in our daily life. Ionic compound such as a lithium iodide, it can use in the battery, while the pen, they contain the covalent compound. In the agricultural sector, the ionic compound such as the ammonium nitrate can use as the fertilizer. The pesticide used to kill the insect, normally they are covalent compound. Medical sector, we have the ionic compound sodium bicarbonate, can use as an antacid to relieve the gastric pain. Paracetamol is a covalent compound to treat the fever. In the domestic use, detergent contain the ionic compound sodium chloride. Glycerol is a covalent compound. So, for the practice 5.7, compare the melting point and the boiling point. Give the one similarity between simple molecule and the giant molecule. Number 3, state the solubility of the magnesium hydroxide. Can magnesium hydroxide conduct electricity in the solid state? Explain it. Diamond is a giant molecule, so compare the melting point and the boiling point of the diamond and the methane. Explain. Predict the electric conductivity of the diamond. So the ionic compound have the higher melting and boiling point than the covalent compound. Simple molecule and giant covalent compound are formed through the sharing of electrons between atoms. Magnesium hydroxide is an ionic compound, so it can dissolve in water. No. In the solid form, magnesium ions and hydroxide ions cannot move freely because they are bound by the strong electrostatic force. The diamond have the higher melting and the boiling point than the methane because they have the strong covalent bond. The methane molecule are held by the weak van der Waals force, so less energy is required to overcome this force. Of course, diamond cannot conduct electricity because it is a covalent compound and it is the neutral. It does not carry any charge. Based on the DNA structure as shown in the figure 1b, explain how polynucleotides coil around each other by using the concept of hydrogen bond. So we have the polynucleotide. So between the polynucleotide, we have the hydrogen bond here. So we have to explain how it coils to each other. A polynucleotide is a covalent compound that has a hydrogen atom bonded to the nitrogen atom. The nitrogen atom is small and a high electronegativity. An attraction force is formed between the hydrogen atom and the oxygen of the another polynucleotide, causing a many hydrogen bond to be formed between two polynucleotides. So polynucleotide will spiral together and form a DNA.